Hello everyone and welcome to today's programming video. In today's video we will solve the leetcode problem, which is to find a node with the highest edge score. So in this problem we have been given a directed graph with n nodes, and each node has a label going from 0 to n-1. So the first node has a label 0. And what's a directed graph if you are not sure? It's simply a graph like the one if you see in this example here, where there is a node, say 1 and a node 0, and you can see that the kind of the lines going, the connections between the two nodes have got an arrow, so that indicates the direction of connection. So that's a directed graph. So for example, again here node 2 is connected to node 0, and the connection is going from node 2 to node 0. And we've also been given that each node has exactly one outgoing edge. So you'll see that no node here in this example again is connected or has an outgoing connection to more than one other node. And we've been given an integer array called edges, and what does it represent? So it's of size or length n, and each element in the edge indicates that there is a directed graph from the node I to the node edges of I. So if you look at this example here, we have been given an array, and let's try and visualize the graph using this array. So if you look at this input array, its indices are 0, 1, 2, 3, 4, 5, 6, and 7. So these are the positions in this array. So here you can see that there is a connection from node 0 to node 1, which is that one. And then next one is index 1, and the value at index 1 is 0. What this means is that there is a connection going from node 1 to node 0. So node 1 to node 0, that's this guy. And similarly at index 2, again the value is 0, which means we have a connection going from 2 to 0. And similarly 3 to 0, 4 to 0. So we have 3 to 0 and 4 to 0. Now we have a connection going from node 5 to node 7. So that's this here. And then node 6 to node 7, and that's here, and going from node 7 to node 5, which is finally here. So we need to find the node which has the highest edge score. Now what's an edge score? So let's say we want to find an edge score of this node 1. Okay, so we need to find all the nodes which are connected or incoming into node 1, and in this case we have just the node 0 coming into node 1. The edge score is 0 because the value here is 0. Now let's look at node 0. Now in this case, node 0 is having an incoming connection from node 1 and node 2 and also node 3 and node 4 as well. Now the edge score for node 0 is 4 plus 3 7 plus 2 is 9 plus 1 is 10. So that's the edge score. So the edge score for node 0 is 10. Similarly, we can check for node 3, and if you see here, there is no incoming connection to node 3. So the edge score is 0. Similarly, edge score for node 4 is 0. The edge score for node 6 is 0 as well, because there's no incoming connection. The edge score of node 5 is 7, because that's the only one coming in. Now let's calculate the edge score of node 7 here. So we have node number 5 coming in, and we have node number 6 coming in, and the total is 11. So now if you look at all the edge scores, 11 is the highest edge score. Okay, if two nodes or multiple nodes have the same edge score, then we need to return the node with the smallest index. In this example, nodes 0 and 2 have both an edge score of 3. Okay, but since node 0 has smaller index, we return 0. So that's hopefully cleared what the problem is and what we're trying to find. Okay, so let's think about how we can solve this problem. So we've been given an integer array, and the indices themselves are the nodes from where the connection originates, and the values at each index is the terminating node. So for visualization purposes, let's look at the array example they have been given. In here we have the indices going from 0 to 7, and we have values at each index position. So now this indicates that we have a connection going from node 0 to node 1, and similarly connections from node 1 to 0, 2 to 0, and so on and so forth. Now to calculate the edge score for each of these nodes, we need to know which other nodes have connections to it. We need to find or iterate this array and find the edge scores for each of these nodes. So we'll have to do one iteration and store the edge scores for each node. So that's the first step. Once we have found the edge scores for each of these numbers, then we need to find the number with the highest edge score. And obviously if two numbers or two nodes have the same edge score, then we need to find the one with the lower index position. But let's look at it step by step. So how do we calculate and store the edge score for each of these nodes? We can have another array called scores. The scores array will be of the same length as the input edges array. One thing to note is when we add the scores together, or the positions of these index values, that number can get quite long or quite large, and int might not be, or integer might not be suitable for storing it. So we will define an array of type long to store the scores. So how do we calculate the scores now? So we iterate through this array, and we store the score for the node 1, for example, in the position 1 in the scores array. So for example, we'll have score 1 equal to 0 because its incoming connection is from node 0. So that's that. Then for node 0, we'll store the score in array position 0, and we can see that its connection is coming from node 1, so its score is currently 1. Then we move to the next element. We see that the node is again 0, and it's having a connection from node 2. So what we do is essentially take this number 2 and add it to the existing score in this position. So we simply say plus 2, okay, because it's the same node here. And we find another node 0 here, and what we do is simply add the index to this score. So that's what we are doing. So we are calculating the sum of the labels or the nodes, or the label of the nodes from which there is a connection to this node. So we have a connection from node 1 to 0, therefore we have 1. We have a connection from node 2 to node 0, therefore we add 2 to this existing 1. We have another connection from node 3 to node 0, so we add 3 here. And we also have a connection from node 4, so we add 4 here. And we get the total edge score of 10. Okay, that's hopefully simple. And then we find a different node. It's 7 in this case, so we store its edge score, which is 5 at the moment, in position 7 in the scores array. So that's 5. we iterate the array as before, find another 7. We see, oh, okay, it's got a connection from 6 to 7, so we add 6 here. Okay, now the next number is 5, so we store its edge score here at position 5, and its edge score at the moment is 7, and we have finished iterating this input array. So in one pass we have calculated the edge scores of each node, and we now need to find the highest edge score. So here it's 11 and this is 7, so that's that. And for the rest of the nodes, if there was any, it's 0, because we have initialized the array, and by default it's initialized to 0, all the values. Let's find which node has the largest edge score. So what we'll do here is let's just draw out our scores array. For node 0, the score is 10. So in this position, we'll store 10. Now we need to find the largest edge score here in this set of list of values, or this array of values. And the simplest way is, we loop through this array, and remember that we need to return not the edge score, but the edge or the node corresponding with the highest edge score, and not the edge score itself. So we loop through this array and keep track of a max edge score variable, and if we find edge score which is higher than max, we'll set max to that edge score. So we'll start off with 10. We'll see, okay, 0 is less than 10, so we'll ignore it. So we'll keep ignoring all this until we find 11, and 11 is greater than 10. So we'll say max equal to 11, and the index, what we want to return, or the node, is 7. In the case we had two nodes with the same edge score. So let's say we have the node value 0 has the edge score 5. The node 3 also has the edge score 5. We need to return 0 and not 3, because 0 is the smallest index with the highest edge score. So we'll have to use the same variable max, but also an additional variable called max position or max at, or something to indicate the lowest position with the highest edge score. So we look at the code, and hopefully that will get clearer. We'll first define our score array of type long, and it will have the same length as our edges input array. Let's populate the score array now. Okay, so what we are doing here is in each position in the score array, we are adding the node from which, or the label from which the connection is coming in. So if you look at this diagram here, so we want to calculate the edge score for position 0, say for example. Then we need to add 1 to it, or store 1 in it. And when we encounter 0 again, we'll add the index to it. Now we can do one thing here. We can have another for loop and check which is the highest edge score. But there's a better way of doing it, and we can do all of that in this one single for loop. For that, we need to keep track of the max score as we calculate the scores, and the lowest index at which the maximum score is stored at. Max at is the index at which we have the maximum score stored. So we have now calculated on line 9, we have calculated the score for the edge, and now let's see if the score is greater than max score. Now there's two conditions here. If the score is the same as the max score, okay, then we need to return the lowest index of the two. So we'll say here is if the score at the current edge I'm inspecting is equal to the max score, then we don't need to update max score, but we need to pick the smaller of the two index values. So we'll say max at. So we'll pick the smaller of the two. Now what if the score of a node is higher than the max score? Then we simply update the max score to be that score and update the max at to be that index. Finally, we just return the lowest index with the maximum edge score. Let's run this code. Cool. Okay. So I'll go through this again once. So we iterate the input array from 0 till the length of the array. So that's from here till here. Okay. And at each iteration, I store the current score, or rather I add the new edge score to the existing edge scores in a new array called score. This populates the score array, but to avoid another for loop to find the highest score, I'm doing this calculation inside this for loop itself to make it more efficient. So I'm saying that, if I found a score which is the same as my max score, then I need to pick the smaller of the two indices. So either it's max at or it's the current index. And if I found a higher score than my max score, then I simply update the max score, and I also set the index to be the current node. And finally, I return the max at, which contains the lowest index with the highest edge score. Thank you very much for watching. I hope you find this video useful. Please remember to like and subscribe. Thank you. Bye.